Good morning, everyone. Welcome. We'll start in just a few seconds after everyone's had a chance to enter the webinar. Okay, everyone, let's get started. Good morning. My name is Pamela Robinson. I'm a professor and the director at the School of Urban and Regional Planning. I'm also the acting academic lead for City Building Ryerson. Welcome to our very first Fresh Voices webinar that we're offering this fall as part of our series at Ryerson. We've recently welcomed a number of new faculty colleagues to our university, and so City Building Ryerson is hosting this webinar series to focus on the wide range of urban issues that our researchers do work on that comprises the big tent that we call city building. We're very excited to introduce these bright minds with their new ideas and their new research, and we're very happy to offer a platform to engage with the Ryerson community and other people who identify as city builders across our region. We'll hope you'll join us for the entire series. We're really excited about it. We think it's going to be interesting. We're also recording this session so that it can be shared, or people who are finding out about it later can come back to it. I'm going to start today with something important. We're going to begin with the land acknowledgement. It's really important that we, as people who are on Indigenous land, are mindful of our connection to the land and the stewardship that Indigenous communities provide. So Toronto is in the Dish with One Spoon territory. The Dish with One Spoon is a treaty between the Anishinaabe, the Mississaugas, and the Haudenosaunee that bound them to share the territory and protect the land. Subsequent Indigenous nations and people and all newcomers have been invited into this treaty in the spirit of peace, friendship, and respect. Those of you who are coming to us from outside our community may be aware that our university has made a very important commitment to change its name. This is part of our process to reconcile the history of our university and the naming of our university after Egerton Ryerson. And the goal is to create a more inclusive future as part of our efforts in truth and reconciliation. If you're interested in learning more about this process, in a moment in the chat, we'll post a link to Ryerson's next chapter page, which outlines the next steps for our renaming process. A few housekeeping notes before we begin. As you know, this session is being recorded, so thank you for participating. We're going to start with about 20 minutes of questions and answers between myself and our guest today, and then we're going to open up the floor to questions from the audience. If you look at the bottom of your Zoom screen, you'll see a Q&A section. I encourage you, as the questions arise, to start putting them in there. If there's a question that someone else has asked that you find particularly compelling or interesting, you can vote it up, and we'll make sure that we save time to get you your questions because we're really delighted that you've joined us. Your microphones and cameras will be off, but you can participate through the Q&A. And then this will be posted later on the City Building Ryerson website. If you're on Twitter and you want to tweet something from today's session, please tag us at CityBuildingRU and contribute using the hashtag Fresh Voices, which we'll also put in the tag. Okay, without further ado, let's get on with the big brain that we've invited to our session today. It's with huge pleasure that I introduce Dr. Roxana Suehring. She's an assistant professor in the Department of Chemistry and Biology in our Faculty of Science here at our university. She received her doctorate in environmental chemistry in 2015 from a German institution, and her research interests include the fate and the transport of organic contaminants, emerging contaminants, long-range chemical transport, high-resolution mass spectrometry, and plastic contamination in urban water. Safe drinking water is, as we know, fundamental to health and safety in communities, and access to safe drinking water is a human right. And our country in Canada has a long history of not upstanding our obligations to human rights, particularly Indigenous communities across Canada, with boil water advisories, which are persistent. In this session, Dr. Suehring is going to tell us about her research on persistent mobile in water and toxic, or PMT as we're going to call them today, plastic additives in urban areas, and their fate and their behavior in the Canadian water system and network, and which ones are priorities from an environmental risk point of view. So this is a really interesting and important session for us all to begin with. So Roxana, why don't you start by telling everyone who's joined us today a little bit about yourself and your research so we can get going.
Yeah, thank you, Pamela, so much. And thank you for the opportunity to join this webinar and to, present my research here and discuss it with all of you. I'm really looking forward to this. Yeah, just a bit of background about myself. So I am from Germany originally, and my background is actually in environmental engineering, and then I've kind of mutated throughout my career towards more and more applying these, in a way, engineering skills of developing new methods, but to investigate pollution problems, particularly in coastal environment, and then getting more and more interested in, okay, what are actually the implications of pollution for regulation, or how can we as researchers inform regulation and work directly with regulators? So I worked as a policy advisor for the UK government and the Netherlands government actually for a couple of years. But then also specifically, I was getting more and more interested in what are the specific transport pathways and mechanisms that enable a contaminant to get from, for example, production facilities or products that they are used in into the environment, and then have the ability to actually expose people, animals, environmental systems.
Roxana, do you remember the time in your research career when that switch first was tweaked for you? Like, what was it that made you decide to commit to this path of research?
Yeah, that is actually, I think there were kind of two parts to this, because one side was that I think I was always more of a scientist than an engineer. So I liked the development of methods, and I liked that way of thinking and the exploration. But I wasn't the person who'd be just developing methods. Like, I wanted to answer questions with that. And I saw while I was doing my master's in engineering, I saw a wonderful talk by an environmental chemist who was talking about pollution issues, and who seemed to combine these two worlds. And so that was where I was thinking, oh, I would like to do that. The other thing that really got me into looking at environmental pollution specifically and at these mechanisms was when I heard about a contamination problem in Sweden, actually in Arctic indigenous communities in Sweden, where specific plastic additives were found in such high concentrations in mother's milk that communities there were asked not to breastfeed their children because it was dangerous. And that was something where I think that was really a pivotal moment for me, where I stopped just thinking about, oh, that's, I want to develop these methods and I want to find out about all of these interesting things, but really said, hang on a second, there's a justice problem here, and we need to do something about this. And how do these chemicals get there that aren't used in those communities, aren't produced in those communities? And likewise, how can we inform policies and regulation to make sure that doesn't happen? And that is really what got me into a lot of the research since then. Okay.
So next question about reach and extension of your work. At City Building Ryerson, I talked in the introduction about how we're trying to pitch a big tent, and that city building is more than the obvious usual suspects. People like me, urban planners or architects or urban designers, or even people who work in urban health or who are urbanists and activists. So tell us, because it's interesting, you built this relationship with us in part because you were on a policy exploration committee at the university, but tell us how you as a scientist also see yourself as a city builder.
Well, and this is the thing, right? Like, cities are such complex environments, right? And so for me, very often when you hear environmental chemist or analytical chemist, yes, city building is probably not what comes to mind. But at the same time, a city is an environment as well. It's an urban environment, and it's actually the environment where most of us humans live in, and increasing numbers of humans live in. And so this means that the city as an environment is actually, on the one hand side, a huge source for different types of chemicals that we are using in our everyday life, right? Be it in the clothes that we are wearing, in the products we're putting onto ourselves, how we are washing our clothes, the electronic equipment that we are using. And at the same time, it's also a place where we can be exposed to a lot of chemicals. Because again, depending on how a city is built, you might not have much buffers against these chemicals, particularly if you, for example, don't have enough green areas, depending on where you live. Are you upstream or downstream of like industrial area? Are you in a more commercial district with lots and lots of streets around you, or are you in a more residential area? What's the socioeconomic situation? And all of that is directly interlinked with those mechanisms I was talking about that allow chemicals to expose people and the environment. So, you know, cities are really, for me, yeah, I think there's a lot of reason to work directly with city builders or, you know, influence one another.
I think we're going to have to change the list of tools that we work with beyond bulldozers and cranes to also include mass spectrometers as part of our city building toolkit.
Absolutely. Everybody should have a mass spec.
True. I'll put it on my list for the holidays. Okay. So we know that you think differently. We know that you work with different kinds of methods and different kinds of tools in your lab. I want to talk a little bit about your research in the Arctic. Your most cited paper to date so far, and just for our audience, you can tell just how new Roxana is at Ryerson because she's sitting in an office where our return to campus is gradual and slow. She hasn't even had a chance to move her books in. That's how fresh her arrival is at Ryerson. She has many books, but they just haven't found a home there yet. Your most cited work is in the Arctic. And so, you know, when I read the paper, I was really intrigued to see how your scientific research is forging connections that everyday folks may not think about between what we do in cities and what happens in the Arctic. So can you help us, can you just kind of paint the story of how the things that we do here have such a vast geographic reach in terms of impact?
Yeah, no, and this is something, again, it's easy to forget, and it was really, or not even think about, right? That, you know, this far away place might be impacted by cities that are somewhere in temperate latitudes, like around here. But, you know, as I was saying, this study in Sweden was really something that drew my attention to this. And then I started working in the Canadian Arctic specifically. And there, what we were looking at was that we were interested in different types of plastic additives. So chemicals used in the production of plastics or as additives to give a plastic a certain functionality. So for example, a lot of chemicals we're interested in are flame retardants to make a plastic less flammable. So this is used in electronic equipment, for example. Or we are interested in plasticizers. So those are chemicals that are used to make plastics more flexible. So these are what we call functional additives. And they are used in all of our products, and obviously they are usually produced also somewhere around industrial areas. So, but what we started finding was that both in air, but specifically in water, we found really high concentrations in the Canadian Arctic of certain types of these plastic additives. And we were really wondering how they get there, because, so particularly the water side, because so if a substance is really long lived in the environment and it can be in air, we often see this, that things are being transported towards the north, and then they stay just because it's cold, and they are less mobile when it's cold. But for these water-based contaminants, this was really not something that was on the scientific and definitely not regulatory radar. So we found these really high concentrations of these, what we call persistent, mobile, and toxic additives that are used and produced in our southern latitudes, but then, so, you know, around Toronto or in the US, but then are transported because of the water flow that is a lot towards the north into these northern communities, and whereby now we see concentrations in, you know, Arctic rivers that are similar to something that you find in highly urban industrial areas, even though it's so far away and those people have no benefit of the use of those chemicals. chemicals. They only get the impacts.
Okay. I know that in your work, part of the community groups that you work with include Inuit hunters and trappers. And this is one of, the experiences that they've had is one of a series of a lot of examples about how decisions that are made elsewhere in Canada have impact on First Nations, Métis, and Inuit communities of people. Can you tell us more about how your research is shedding light on the behaviors we have here and what it means in those communities? And also really importantly, because, implicit in city building is a call to action, like what change are you seeing happening? And also what's the change that needs to happen? Walk us through that.
Yeah, no, thank you for that question. So yeah, and I really want to give a shout out to those communities, to the Inuit hunters and trappers who've been absolutely, amazing and instrumental to enabling our research. So we've, for example, been looking at, in terms of pathways of those chemicals into the Arctic, how are birds and seabirds involved with that? How are these chemicals then also impacting traditional food sources? And there, we would not be able to, get these samples or, get them safely without the local communities who are really, helping us with that. But yeah, absolutely. With your question, what can we do? And particularly with these more, what I call persistent, mobile, and toxic chemicals, we have a regulatory lack here, quite frankly, because for non-water soluble plastic additives, for a lot of them, we have regulatory frameworks. We have processes of how to risk assess them, how to make sure that they don't have an impact. But with these more water soluble plastic additives, they've just really not been on the radar of regulation. And so here, a shout out to one of my students who's been doing an absolutely fantastic job over the last few months, who's actually going through hundreds and hundreds and hundreds of chemicals registered for use in Canada, plastic additives, to try and identify these mobile toxic plastic additives and investigate whether these are a priority in terms of environmental problems, particularly the question of whether they are being removed in wastewater treatment plants. Right. And what she discovered was that actually of all the what we call PMT plastic additives, and we have around 200 of them used in high concentrations in Canada, more than half are not removed by wastewater treatment plants. So this means when they are used in cities, which is their dominant use pattern, they will just go through wastewater treatment plants into, for example, Lake Ontario, with one on the one hand side is a potential problem actually for Ontarian Toronto drinking water. But also because they are so long in the environment, they can then travel all the way to, for example, up the St. Lawrence towards the more Arctic regions. And so what to do about this? So one of the things is really ensure that this mobility, the ability for a chemical to move through water into drinking water sources, into groundwater sources, is recognized as something that needs to be regulated. And for some of those chemicals, quite frankly, it's also really something that consumers can ask to not have that, to have something that's free of those chemicals. So for example, there are the per and polyfluoro alkyl substances, the so-called PFAS, that are used in a lot of outdoor clothing as a surface treatment to make them waterproof and non-stick. And those, quite often you can actually ask for, I want PFAS-free outdoor clothing when you buy your next jacket. And that will honestly already help also from the consumer side of things to keep yourself safe and the environment.
Such a great irony in everyone who loves the outdoors wearing clothing that's actually contributing to the degradation, right? There's this process in retail work called choice editing, where people providing goods and services actually just stop selling the things that shouldn't be sold. And so in addition to people asking, maybe we'll start to see, well, Mountain Equipment Co-op isn't a co-op anymore, but maybe MEC or Patagonia will commit to PFAS-free outdoor clothing. Okay, I'm going to ask one more question, and then I just want to, we'll happily open it up to the audience. So people who are listening, please put your questions in the Q&A. I have other questions, but we really like to hear your questions too. I want to just focus on a research collaboration that you're involved with that lands in our university. You're a researcher with our Urban Water Research Center, which for folks who know Ryerson may know it previously as Ryerson Urban Water, but the organization has changed its name. So it's an interdisciplinary group of researchers, and their work focuses on, which isn't a surprise, urban water. Tell us about how those collaborations impact your scientific research, but also like what you think you're contributing back in that interdisciplinary space.
Yeah, and this is something that for me as an environmental chemist, you know, we like to put ourselves into certain labeled boxes, right? But at the same time, I never work with just other environmental chemists, for example, or even other chemists for that. So my work, because any environmental system, any environmental problem is such a complex mixture of different types of what you might call disciplines or ways of thinking, right? In terms of finding solutions. So, you know, if we want to regulate these chemicals, we need to talk to people who are regulatory experts. We need to talk to social sciences. When we want to see where are chemicals going within urban waters, for example, we need to know something about the urban system and the differences within, for example, a city of Toronto. So often contamination from a city, from an environmental chemistry point of view, is just seen as, oh, a city is this big black box that spews out chemicals. But obviously that's not true. A city is a complex mix of different types of land uses, basically. And so with that, like talking to, city planners, city builders, spatial analysis, geographers, for example, is really, really helpful. And then of course, you know, if we want to talk about impacts, we want to talk to biologists, to ecologists. So all of this is really, you never work alone on these topics. And it's actually one of the things I love about my job.
You know, if it was simple and easily done alone, it wouldn't be a problem, right? It's
exactly.
The things that require the complex series of brains. Okay, I've got two questions from people who are participating today. The first one comes from Kelly Okamura. They write, I'm interested in cigarette waste, particularly the plastic fibers that make up the filters. Their understanding is that plastic fiber filters bypass the water filters in the sewage treatment plants. Can you comment on the impacts of this form of plastic, as it's one of the top two items going into landfill, but also on the global problems in terms of water? The understanding of the person asking the question is that the infiltration is harming water and food. Great question. Thank you, Kelly.
Yeah, thank you very much, Kelly. This is an excellent question. And so the thing with a lot of fibers, there are a bunch of different problems around this, and particularly, so this is for, you're absolutely right, cigarette filters essentially are plastic fibers. And with any type of plastic, usually what happens is that they will not degrade in the environment. So they won't disappear. They will just break down into smaller and smaller and smaller and smaller particles. And so then the problem is if you get to really, really small scales, they can get uptaken into bodies of different animals or humans as well. And if they are small enough, you know, even get into through membranes into cells and so on. And so at this point, it gets really, really difficult to remove them from, for example, from wastewater treatment plants. The ironic thing is that the removal efficiency for a lot of plastics, plastic fibers, or a lot of microplastics off wastewater treatment plants is actually pretty good. They are good at removing those. The problem is there is so much of this that comes in that even though a lot of wastewater treatment plants have like 80% plus removal efficiency, so way, way more than for these PMT substances we just talked about, there's just tons and tons still coming out on the other end, just because there's so much coming in. So with a lot of those plastic problems, really what we need to start doing is to reduce the initial use and emissions, because this like sort of what we would call almost like end of pipe solution, like a wastewater treatment plant, is just not doing enough. But
It's
yeah,
really
really
interesting.
excellent question.
You know, neighborhood business improvement areas in Toronto are experimenting with different forms of cigarette butt waste disposal. It's like super low tech. It's like in my neighborhood, it's a blue bucket. It says butt out with some sand in it, right? I also wonder if as people switch from cigarettes to vaping, different mechanism for receiving nicotine, if we'll start to see a decrease. It really grinds me though, the number of people who just chuck their butts out the windows of their cars. It's like one of those, it's really annoying. But there's an interesting example, I think, of an environmental issue where the actions coming across engineering and across neighborhood business improvement. So, and individual behavior change. Okay, another question. This comes from Peter Miazik. In addition to PFAS, can you please list perhaps 5 other PMT additives of greatest concern?
Yes, thank you, Peter. Excellent question. So there are a whole variety of different types of substances. In terms of substance groups that are the ones of most concern in terms of that they are persistent, mobile, and toxic, and have very little removal in wastewater treatment plants. We're talking less than 10% removal here. You see a lot of colorants, so dyes that are used to, well, dye different plastics. There are also surface treatment agents in general. So these are the PFAS, but there are also other substances like, for example, organophosphate esters that are used as surface treatment agents. They're also used as plasticizers and flame retardants. And those were actually these substances we found in these really high concentrations in the Canadian Arctic Ocean. Some other substances, and these are really substance groups. There are, amongst others, from the toxicity point of view, a particularly concern are biocides that are used to essentially, again, they are surface treatments for plastic products that are in contact with, for example, even water, to make sure that you don't have bacteria sticking to them. So those are some of the examples that are of particular concern.
Okay, great. I'm going to take one last question and then we'll wrap up the formal part, and then we'll just let everyone know that we're going to stay on if you want to ask Roxana other questions, but we'll end the formal Q&A after this one, and I'll share a good comment too. How do you see your work on PMTs impacting chemical regulation in Canada 5 to 10 years from now? And I'm going to add, as a scientist, how receptive do you think and persuasive can your research be in terms of impacting change in terms of legislation?
Yeah, and this is an excellent question, right? And this is actually, exactly that question led me leave academia for a couple of years and be a policy advisor because I wanted to ask exactly that question or answer that question. How can I, as a scientist, inform regulation? Who are the contacts I need for that? Because this is what I found out very quickly is it's basically most of the time not that you're writing the most amazing paper, but whom did you talk to? And so by now I am really privileged that I have a lot of contacts to regulatory scientists across North America as well as Europe. And so, for example, on those PMT substances, I right now have a contract with Environment and Climate Change Canada because they are, after us having a conversation, they said, okay, this is something we are missing on our regulatory radar, basically. We need to start thinking about this. And developing from that, we are right now talking to the ministry, MECP, to hopefully start setting up follow-up research on that. So we're really, I am hoping that then the information that will be really, grounded in that truth and what do we actually find in Lake Ontario, what do we see here in Toronto, that this will really spark regulatory change and scrutiny for these types of substances.
Okay, thank you. So I just want to know, Catherine Bushmay reminds me that there is still waste from vaping and the cartridges are becoming the new cigarette butts. Duly noted, Catherine, and we'll get the BAAs focusing on those too. Okay, last question from me to you, Roxana, before we end this formal part. What's next? You're new, you're getting started. your research has momentum. Where are you turning your attention next?
Oh, there are so many cool things to do, right? One of the things that we're actually doing that I'm really excited about is we are trying to bridge the gap between seeing where these additives, where these chemicals, plastic additives end up, and seeing where their emissions come from. So bridging the gap between pollution and polluter. And we have a really wonderful project with collaborators within Canada, again at Environment and Climate Change Canada, in the UK, in Germany, and in the US, where we are looking at forensically identifying polluters based on the patterns of additives that we find in local environments related to specific types of plastic products. So there we're working with forensic chemists who usually, advise the police and run like investigations. We're working with polymer scientists. We're working again with regulators. So really really interdisciplinary team to try and actually say, well, if we find this here, can we identify basically who put it there? Okay. So I'm very excited about that.
That's great. Roxana, we could have probably filled 2 hours with talking about your research. I'm going to formally say thank you right now. Thank you to everyone who came to participate with us today. Thank you to the team at City Building Ryerson for helping us make this happen. And most of all, thank you to you. Thank you for coming and sharing your work, but also, it's a really wonderful thing to have a research colleague who sees the connection between their work in the lab, their work in the Arctic, and City Building Ryerson and the broader community in the Greater Toronto Area. Thanks so much for coming, everyone. If you've got a question that you'd like to ask directly, but you didn't feel like you wanted to ask it in the formal session, feel free to stick around. Roxana is really happy to hear from you. I'll end by saying we hope you'll come back and join us on October 20th. We've got Will Galloway from the Department of Architectural Science talking about massive urban change in Japan. So we're hopping geographies, we're hopping disciplines, and watch for this webinar to be posted on the City Building Ryerson website soon. Thank you, everyone.
Thank you so much. And yeah, I'm still around. I'd love to have more questions and have a chat with you guys.
Yeah, if anyone wants to stay, we're here. I thought you got great questions.
Yeah, no, that was.
I'm happy people ask those questions.
Yeah.
If anybody's sticking around, we're happy to hear from you. Put a question in the chat or in the Q&A. Oh, Kelly raised their hand. Luke, Kelly, we'll go to you. Luke, can you let Kelly speak? Turn on Kelly's microphone. Is that possible?
Hello, can you hear me?
We can. Nice to meet you, Kelly.
Hi, and thanks. I'm a Ryerson grad, and that's how I came onto the call. I was really interested, Roxanne, in terms of your work and focus, because I've certainly followed the U of T in terms of textile fiber. My background comes from Ryerson fashion, and my industry is new product development. I've gone from the top of the pile down to waste and ended up in cigarette filters. I'm really excited by the support in the St. Lawrence Neighborhood Association to start a project that I think has great scalability. And I bumped into an obstacle at the city level when I need their infrastructure. We were hoping to collect those butts. We can they're paying $1 a pound, which is far less than the cigarette company should be paying. But on the other hand, we can take that into transforming that plastic into creating it into a community bench, and that's our goal. So I could use some help in terms of a research of science bases, in terms of what's going on at the city level that you're not on board. You could take global leadership on this one.
Yeah, that is really unfortunate to hear. Like you would imagine that they would be more supportive of that. But I thank you so much for this really fantastic initiative. And I would actually love to hear more about that. So if you want to send me maybe an email, I would love to chat more about this with you. I actually, right now, I have a graduate student who's also looking at innovative ways of dealing with non-recyclable plastics, like, cigarette butts would totally fall under that. And I think this would be a really, really interesting point to look at and talk to, what are these resistances actually?
I appreciate knowing that you would welcome that new conversation.
Absolutely.
My background is in systems changes innovation, and so I'm really interested in working or taking this into that science area that I simply don't have at the moment.
No, thank you so much. Like, yeah, I would absolutely love to continue that conversation. That would be brilliant.
I've left my email in the Q&A, but and hopefully I'll be able to find you as well somehow.
We can, if you give us a second, Claire, I'm not sure if your fingers are free, but if you could put Roxana's email in the chat or answer Kelly's question, that would be super helpful.
Thank you.
Roxana, there's two questions that came in the Q&A just as we were wrapping up, which I think are good. Karen Warsick writes, are you going to be looking at how waste disposal contributes to contamination by plastic additives, both in terms of incineration and landfill?
Yeah, so that's another huge one, right? Yeah, you're absolutely, that's a really excellent question. So, and so one of the things, so leachate from landfills is definitely a huge problem with regards to potential emissions of these plastic additives. In terms of incineration, we personally right now do not look at that, just because we are really more in the water phase, and then incineration classically is more an air problem. And so we have other colleagues who are specifically looking at that. But yeah, it is definitely the question of how is waste contributing to leachate is really, or to these additives in the environment is very important. Another question there is actually also, what is the impact of recycling on these additive patterns? Because very often what we see is that mishandling of waste and mishandling of recycling streams can lead to recycled materials having high concentrations of additives. So, or that specific use of additives can actually be a barrier to recycling because these additives are so hazardous, so toxic. And so that is one of the questions we have as well, is like, so to what extent are these additives a hindrance to recycling, or can actually then make recycled plastic more problematic?
So Julia, I'm not going to be able to do your last name without practice, so I won't take advantage of it. Has 2 points in here. Julia asked, are there changes we can make in terms of the consumer end of buying or not buying certain products? And Julia also suggests, which I think is an awesome idea, this would be a really amazing river talk. Ryerson or Toronto has all kinds of interactive kind of ecological education processes, including like the Buried River Project. But it would be a really cool Jane's Walk, for example, to do a walk through the city. So Julia, that's a really good idea that
I love that.
Might have to noodle on. Okay, but back to the consumer question, like, are there things we can do? Yeah.
So I think, so one of the things, there are a lot of really wonderful examples of where consumers asking these nagging questions when they are buying, for example, outdoor jackets and so on, actually changing use of certain chemicals. So we've seen this with some flame retardants that I talked about earlier that were used in, for example, children clothes and children bedding, and then they were found to be a massive health problem. And so by consumers continuously asking for, I don't want these types of chemicals in the stuff that I'm buying, companies started asking their suppliers to not put these chemicals into the products. Or also starting labeling requirements. So where you could actually just have a look, is this PFAS free? Is this free of brominated flame retardants, or whichever chemical you're worried about? So this is something that you as a consumer can definitely ask for. Another thing is also, and this is actually a conversation that is being had and that I think needs to happen more also within the public realm, is the question of, do we really need to use all of these chemicals to begin with? Because very often a lot of chemicals are just being used as a default, or they're being used for convenience sake, but there are other alternatives, or it's even possible to not use them at all. And so there's been this whole discussion in the scientific and to an extent regulatory community of what is called essential use. But then the question is, how do we define what's essential? What is essential for us as a society? And this is something that I think the public should a lot more be involved in with these types of questions and discussions. Yeah.
Okay, Kelly, I just emailed you back in the chat through the Q&A and answered your question. I don't know if you can see it or not though. Let me know. But Roxana's email is roxana.suehring@ryerson.ca. Okay. Let me just see. Okay. Brian writes, I'm a volunteer with Lost Rivers Toronto, which researches and leads walking tours along the waterways. They'd love to develop one that focuses on plastic with you.
Oh, thank you so much. I'd be very excited.
It'd be really, that's the kind of thing that could be incubated in a bunch of different ways with students too on Ryerson.
No,
right?
Absolutely.
Yeah. There, it's one of the things that my brain was firing as I was listening to people make suggestions today. Thinking about like repurposing cigarette butts into plastic benches, for example, between Ryerson zones and other kind of interactive student learning opportunities. Those would be really cool studio projects that may find homes in different places. And also, Roxana, listening to you talk about consumer choice, you're in the Faculty of Science. We've got a School of Retail Management in the Ted Rogers School. Sometime it would be really interesting to connect the dots there and the School of Fashion too, right? How do we train designers to only work with fabrics that are PFAS free, right? Like there are lots of kind of really early foundational laying things that we could start to do when we start to gather folks in situations like this, right? When we start listening to each other's research, that's part
Absolutely. Of it. And this is also talking directly about city building, for example. Yeah. So quite, directly in a lot of houses, the insulation that is being used is full of, for example, specific types of flame retardants that can leach out and can get into dust into people's homes. And there are alternatives to the ones that have potential health impact. Right. So again, there is, for example, so if you're planning on building a house, for example, to actually ask, well, I don't want brominated flame retardants in my house. I don't want that in the insulation. There are other ways of doing this, but it's very often the cheapest way. And so that's what people default to.
But, it's also interesting, like the City of Toronto has the Green Building Standard, right? And it would be interesting to see if there could be a policy connection there where it's a lot for individual consumers to try to keep track of everything, right? Absolutely. I mean, people are already trying to do it with food, and that's a big piece, right? But trying to find upstream policy levers that narrow the choices so that the options are only the ones that are good moving forward makes it easier, which Catherine says the problem is that it's up to consumer, right? And that she's not a chemist, but there are some policy changes or at least guidelines and recommendations that could come. And we've seen that happen. Like if you look at seafood, for example, I know that the labeling system around what is so-called sustainable seafood is a bit fraught, but it does mark progress in terms of giving consumers more information at the point of choice. But it would be even better on the building side if we just said we're not going to actually allow anything to the local building code to be used to build that isn't safe and isn't PFAS free. So,
well, and I think this is actually a really, really excellent point. Yes, consumers have a lot of power in their choices, but at the same time, this can't be the responsibility of all the consumers that you all of a sudden need to become an expert on all of this. In all of your different areas of life, basically, to try and keep the environment and yourself obviously safe. This is something where there needs to be regulation and where there needs to be information for people rather than them having to dig up, oh yeah, maybe there could be something wrong here, right? So there needs to be a lot more, in my view, a lot more proactive, be it labeling, be it information, or just downright restrictions.
There's also a really important equity piece to it too, I think,
Absolutely.
in that, you know, we've seen this with other environmental forms of building, that when things were built into, for example, the LEED Green Building Standard, the cost of the green enhancements came down because they became the industry norm. And so there was production at scale and economies of scale that made those materials cheaper because there were more of them. We don't want to create a situation where only wealthy people have access to cleaner, greener products. And so along with the environmental protection, there needs to be an equity piece to it, where we're
Absolutely.
not just downloading the more toxic products into situations where less affluent people can afford to work with them, right? So it's interesting. It's a bit of an economic puzzle, but we have seen progress in other goods where when the green standard becomes the baseline, the price is relatively less expensive because of economies of scale and production. So
no, and I absolutely agree with you. And I think this is one of the things, you know, we see in our research a lot as well, that, you know, it really matters where you come from socioeconomically, you know, underserved communities, for example, equity seeking groups are the ones who are most impacted and often most exposed as well to a lot of these chemicals because of, for example, having older infrastructure, or also often living closer to, for example, industrial areas because housing prices are cheaper there. And I absolutely agree. This is so important. And also particularly, again, from the city building side of things, to actually think about, okay, how can we mitigate impacts? How can we make sure that building standards aren't, you know, completely different, just, you know, because, oh, this is a lower income community, so here we can use the more toxic materials, you know, I mean, seriously. But likewise, this also comes with how can we build more resilience to potential exposure through having more green spaces, which, you know, we've seen there's evidence, right? Scientific evidence on that reduces emission loads and it reduces defects. It increases the resilience.
And yet we know that the distribution of the tree canopy is significantly correlated to people's socioeconomic status in the city.
Exactly.
Yeah.
And so those are all things that really, you know.
And this is where the complex system of city building really is all hands on deck, right?
Yeah,
and that's why research like yours, in combination with the folks in fashion and in building science and planning and retail management, all needs to come together.
Absolutely.
Okay, I think we're going to end on that note. Thanks to everybody who stuck around. Nice to meet you all. We're really glad you joined us. I hope you'll come back and keep listening to our other Fresh Voices talks. One of the things I most love about being a faculty member at this particular institution is that people often come and join us in part because there's a desire to take the research, which is rigorous, and move it out into practice and to make a difference with it. And that part's not always recognized in our own disciplines. Hey, Roxana, impact is measured by citations. It should also be, measured by policy change on the ground. But I feel like there are lots of us at Ryerson who really want to kind of put that research into action. So thank you so much for coming. Thanks to everyone who participated and asked great questions. And it was great to learn about new points of community contact. We wish you all well, and we'll hopefully see you on October 20th for Will Galloway's talk. Take care, everybody. Goodbye.
Bye.